Okay, let's finish the last two questions on this. So we have a block. We have a block of, it's a metal. It's unknown. We know the volume and we know the mass. And so let's find the density of the metal. We take the mass and we divide it by the volume. So 235 grams divided by a volume of 2 or 5 times 3 times 2. So that's 235 grams divided by 30 centimeters cubed, and that's 7.8 grams per centimeter cubed. Now we have to go to our textbook and we look up the density of that, and we should find out when we look it up that it is steel. So the question is, will steel sink in mercury? Mercury is very high, it's like 18.3, and so no. If we had liquid mercury here and we put steel in, it would float because its density is only 7.8 and the mercury is 8.3 grams per centimeter cubed. Next, if the buoyant force is less than the weight of an object immersed in a fluid, what would happen? This is kind of like the bottle question I showed you with Archimedes' principle. So here's the water. If we have an object and we have this force acting up on it, that's the buoyant force, and it's strong, so let's make it a long arrow, and the weight is tiny, or sorry, the weight is lots and the buoyant force is tiny is what it's saying. So let's erase that. So a nice tiny little buoyant force arrow. What's going to happen? This object is going to sink because this is a strong force. That's the force of gravity, and this is weak, so it will sink. And another name for sinking is it's negatively buoyant. Okay, so we're done that one. If the buoyant force acting on the object's weight, if the buoyant force is equal to the object's weight, what will happen to it? We've seen this before. Here's the water. So these two forces, this downward force of gravity, which is its weight, and the upward force exerted by the fluid, which is the buoyant force. If these two arrows, these two forces, if they're equal, then it just hovers. And another word for hovering is neutral buoyancy. Okay, let's look at the third situation. Obviously, it has to deal with something being positively buoyant. So positively buoyant. But this time they don't want it. They just want us to have an object. They don't want to tell us what's going to happen. Give an example of what can happen when the buoyant force on an object is greater than that. Okay, well we could take lots of examples. So if here's our box, now this is really strong, this force, and this force is really weak. What will happen? It will start to rise up in the water. And there are lots of examples in nature about this. We could take a hot air balloon, for example, and here's the basket. When the hot air balloon fills with hot air, that hot air is lighter than the air around it. Here's the ground, and it will rise up. We talked about fish in the book. Fish have swim bladders in here, so this is their swim bladder, and they can fill the swim bladder with lots of air or oxygen from the water, and they can make their buoyant force really strong compared to the force of gravity, and they will rise up in the water. Or we could even talk about a submarine. Submarines have ballast tanks, and those ballast tanks, we can put water into them in the submarine. So here's my submarine, and inside, kind of like swim bladders, they have ballast tanks, and that ballast tank can have air in it or it could have water. If it has